Are you a real-time application developer who has a need for uninterrupted real-time performance and may be interested in the lowest latency possible in your application? If so, then please listen to this technical overview of Concurrent's NightTrace tracing tool. NightTrace is one of Concurrent's Nightstar suite of development tools that provides a precise timeline-based system trace to examine timing anomalies in a Linux system. NightTrace has a command line interface and a GUI interface to control the capturing and display of kernel and user trace event data. The output of NightTrace resembles that of a software logic analyzer. NightTrace provides configurable data collecting daemons to gather trace data. These daemons can be customized and activated together or separately to collect user data, kernel data, or most helpfully, both simultaneously. Kernel trace data is used to show you exactly what is executing on each of your processor cores on a sub-microsecond timeline, even virtual cores on a hyper-threaded system. For each core, you are shown every interrupt, system call, CPU exception like page faults, and a process and thread ID graph. Kernel trace data is invaluable when looking for anomalies or sources of latency and non-determinism in an application. NightTrace provides search and statistical summary tools which help the user search for specific events or summarize defined states. For example, here we have summarized the occurrences of a specific subroutine in our trace data looking for anomalies. Our summary graph highlights all occurrences of our subroutine where the height of the graph represents the length of time the subroutine is executing, the red arrows. This graph or summary data lets us easily spot the anomaly shown by the long spike in the chart, the blue arrow. Returning to the user and kernel data display page, we can correlate this anomaly in the user code, the red arrow, and identify its cause in the kernel data, the blue arrow. Regular or random sources of latency or non-determinism like hardware interrupts, page faults, or process preemption can be easily identified using this method. Precise sub-microsecond timings can be obtained from either the events list at the top of the page or the hover time box at the bottom. Here we place our timeline at the beginning of a local timer interrupt on CPU 2 and hover our mouse over the end of the interrupt to read that this interrupt is about 6.6 microseconds in length. This shows the level of visibility that NightTrace gives the user when examining the trace data. The values of variables in user code can also be captured in a trace. Here, notice that prior to entering subroutine A1, the value of pressure is about 878.02, and after entering, pressure changes to about 878.42. This demonstrates how variables in user code can be easily correlated with the trace data over time. All NightTrace kernel data is available anytime by simply booting the trace-enabled Red Hawk kernel. User tracing is available when the user has instrumented his source code with trace events or compiled it with application illumination for automatic insertion of trace points around function calls and returns. Achieve sub-microsecond visibility into your real-time application with NightTrace and Red Hawk Linux. Please contact us for a more detailed demo or to arrange for an evaluation copy of NightTrace. Thanks for listening.